Hello. Today we're going to be learning how to construct a table for a 5 by 5 type experiment, how to calculate mean and standard deviation, and also how to construct a line graph along with appropriately programmed error bars and to calculate a line of best fit and Pearson's R value and interpret it. So what I have on my screen here is what we're hoping to wind up with at the end of the class. So again, notice we have an appropriately titled table with the model organism, the variable that we are measuring, as well as the precision and units that it is measured in. And then over here, we also have the independent variable with those same features. I constructed this table slightly differently just to show you that you could calculate the table or calculate in two different ways on Excel. So in the previous example over here, we had our independent variable was in columns and then our dependent variable was in rows. On this one, we have our, the independent variable is in rows and the dependent variable is in columns. It will still work the same way no matter what. So first what we need to do is go construct our table over here on this blank workbook. So I'm just, for time's sake, I'm just gonna cut and paste the title of the table. I'm gonna put that somewhere up here. Then remember that we need to have our N number, okay? And that's going to be across the top here after we put our label. The label here. Okay, so our N number, I just put a little arrow to show that it's going across the top. And if you remember from the previous video, if you type in your first two values, then left click, hold, and drag to select. If you hover your cursor here over the green dot in the bottom right hand corner, you get a black cross. If you drag it, then that will program Excel to automatically fill in your counting. Okay, so you don't have to type it in the same each cell. Okay, these I'm gonna just cut and paste. Okay, so in this example, what I had here was the question was the effective salinity on the final height of a mung bean sprout, basically. So we used these salinities, 0, 1, 2, 4, and 8%. And then we did that by making a serial dilution. So we started with 8% salinity and then diluted it in half all the way down, with the 0 being the control as pure water. Okay, and before I input my data, you will notice that I have an extra 2 columns here. Okay, so what do you do when you have 2 extra columns? Well, if you left click on column A and hold it and drag it to column B, now I've selected all of column A and column B. I can right click and just hit delete and I'll get rid of those columns. Okay, I just kind of grabbed a spot on the page without thinking about that. And also, you'll notice in this table, I bolded all my titles, and they are not bolded here. I also need to put where I'm going to have my descriptive statistics. So I can just left click and drag until I've selected everything, and I can hit bold to turn them all bold, these copied over, or what you can do is left click and drag and then hold down the control button and then select these 2 cells, because, and then hit bold. This cell C1 actually doesn't have text in it, and neither does the mung bean height. If you go back to here though, you can see this title is actually going from cells A through H, and then this one's going from cells B through F. So how I do that, go to A through H. I'm going to select all of those and I'm going to hit right here under the home ribbon, merge and center. So now I just have 1 cell, and then I don't have to worry about resizing or anything. And then I'm also going to do the same left click, drag and hold from B through F. and then click merge and center as well. So I have my table centered, my table title centered on the whole table, and then the dependent variable centered around my data set here. But then that still leaves me with this. If you can see, salinity label actually carries over into here. Well, I don't actually want to merge these two cells because maybe I need to do some math down here. So instead, I need to resize this column to fit this label. I'm going to do that by going between column A and column B. So you hover until I get this line with arrows going both ways and double click, and that'll resize the column for me. You could also have done it by clicking up here and double clicking and it would resize all the columns. But in this case, I don't like that because I'm going to need these wider in just a little bit so that my data will fit. So I'm going to hit undo, go back a step. Then I'm going to select my data and just cut and paste it over. Now you will be entering your data in manually. Now it's important to remember this is a rule for all of science, not just for IB, but if my ruler is measuring to the 10th place, then every single data point here needs to be to the 10th place. So as you're typing, you may notice when you type in this 3.0 that Excel automatically changes it to 3, or the 16.0 automatically gets changed to the 14 or the 16, okay? So the way around that, type in all of your data as you normally would, but then left click, drag, and select it all. And you can toggle up here the increase or decrease decimal points. Now I have 2, and that's too many, so I can decrease. Or you can click this menu here, number format, and just make sure that number is selected, and then you can toggle up and down however many decimal places you want. It is important that all of your data matches the precision of your ruler or measuring instrument. This is because of this, it's also very easy to tell if I had a student using American units. They then converted into metric because you'll have lots of decimal points that you didn't actually measure. And remember, it's important because if I had typed out, for example, 21.12, whatever, what that tells me is I have an extremely precise measuring instrument. Like that's what it means to a scientist, that I measured accurately all the way down to this decimal place, which is not true. An instrument of such precision would be quite expensive, and a high school lab would not be able to afford that. Okay. So the precision does matter, and on your IA, the examiners are checking that. Okay. So now what we want to do, as with every one of our experiments, we need to calculate our descriptive statistical tests. So in our case, we're using mean as a measure of central tendency and standard deviation as a measure of the variation in our data set. So hopefully you remember how to do this from the last video on the t-test. It's the exact same thing, except now we're going across in rows. So click on the cell where you want the mean to be reported, and you can just type it directly in if you know how to do it, equals average. Okay, and then a parenthesis, open parenthesis, left click, hold, and drag for the 5 values we want the mean of, and I'm going to close the parenthesis and just hit enter. Now you'll notice I got an error message. So if I hover over it, it says formula omits adjacent cells. So this is Excel telling me, didn't you want to include the 0 over here? Well, no, I didn't. Okay, the 0 is a label for how much salt was in that solution. So I'm just going to hit ignore. You can leave a little green flag there if you'd like, but it doesn't really matter. Okay. Another way to do this, if I delete that, is remember to go back to your formulas ribbon and go to more functions, statistical, and averages right here at the top. And when you do it this way, Excel is trying to guess where your data is, And you'll notice it guesses A4 to F4 because there's numbers all the way to the left of this formula. But that is not correct. We do not want to include A4 in this. So we can just highlight and delete and then select only B4 through F4 and then hit OK. Okay, and we get 16.2. I'm going to ignore the error again. And then remember, just like we did before, you can put your cursor here in the bottom right-hand corner so that the white cross turns into a black cross. Left click, hold, and drag it down. And now we have the mean for each of our rows. Now, the rule for significant figures is when you're doing any kind of multiplication or division, your significant figures need to be rounded to match the fewest number of significant figures from your original data set. So for this cell, G4, my original data set is here. So if I look, there's 3 significant figures, 3 significant, 3, 3, and 3. So this needs to be rounded to 3. Excel won't round to significant figures. It will round to decimal places. So it's possible you may need to toggle these decimal places. It looks like mine were already pre-rounded since I copied my data from a previous workbook. Okay. This one, I've got 3 significant figures here, but my data is 3, 3, 3, 3, 3. Okay, so that one's okay. This one is 3 significant figures. I don't like all these errors. Okay. But here we've got 2 significant figures, 2 and 2. So that means I actually need to bring this down to only 2 significant figures. So to round it down, I need to go back to the Home tab, and I need to reduce it by 1 decimal place. And you'll notice it was at 10.7. When I go down a decimal place, Excel automatically rounds it for you. Make sure you're letting Excel do the work and not you. Sometimes students will see that 10.7 and they'll say, oh, it's that's 11, and then they'll just type in 11. Well, now we've got a problem here. It's 11.0, and we've removed that formula. So again, if I realized, oh, that wasn't supposed to be 9.3, that was supposed to be 9.8, I just couldn't read my handwriting. Well, now this didn't change, okay? Let me go back a couple of steps. So now if I put the formula back in, if I realized I had made an error, 9.8, if you watch over here when I hit enter, okay, the mean automatically changes. So that's why it is important to keep those formulas in. Do not do anything in your head with Excel. Use the formulas. Okay, so I still need to round this to 11. Now this one, get rid of this error. This one is 2 significant figures here. I have to check my data, 2, 2, 2, 2, 2. So that one's okay. And then this one is 1 significant figure is what it's rounded to. So I have to check this one's 1, 2, 1, 1, 1. So this is correct. It should be at 1 significant figure. Okay. Now we need to figure out the standard deviation, SX. So to do that, we're going to go back to the formulas ribbon. Make sure you've selected the cell where you want that formula to go. We've got formulas. We're going to go to more functions and statistical, and they're all in alphabetical order. So scroll all the way down to the S's. And if you remember from the last video, there's several standard deviations. We always want, in our biology class, we're going to choose standard deviation S, which is the sample. So click that, and now it's telling us, okay, which cells do you want to calculate for? So we want to calculate these. Remember, do not select the mean. You don't want that in your calculation. We want the standard deviation of our data set. So left click, hold, and drag, and you can double check with the cell names. So we want B4 to F4. So we're going to hit OK. And then we'll apply this formula all the way down by selecting this green dot. Left click, hold, and drag. Okay, and again, we've got errors. Okay, yes, I'm sorry, I did these ones individually. Yes, if you left click, hold, if you have everything selected, you can choose to ignore all the errors at once. I did it the long way around to start with. And you'll notice again, we have rounding issues here. So standard deviation, the formula does use multiplication and division. So we need to round this down. We already calculated the significant figures we need. So this needs to go down to 3. So I'm going to toggle this down until I see 3, 1, 2, 3. This one needs to also be 3. Okay. This one needs to be 2. And then auto rounded for me. And that one needs to be 2. And then this one needs to only be 1. Now notice this and this both have 2 digits, but this one only has 1 significant figure, because if the value is less than 1, the 0 before the decimal point does not count into the significance. Okay. All right, so now we have our data table. So the next thing we want to do is construct this graph. Okay, we'll do the Pearsons at the very end. So we're going to construct a line graph. Okay, so again, let me go back. You'll notice that I do not have 25 points on this graph. We only ever want to graph processed data. Okay, so you're going to graph each point is going to be, we're going to graph the mean, and then the error bars will be the standard deviation. So the way this is working is this over here was my independent variable. This is going to be my x value. So you'll notice on my graph I already constructed, it's 0 through 10. Okay, but I have points at 0, 1, 2, 4, and 8. That's my x value. And then the mean column is going to be my y value. So what we're going to have to do is, it's easiest to do this first, is left click, drag, and select your x values. You have to always select your x column or your x rows first on Excel. Then hold the control button, okay, and you can let go of the left mouse button. So let me start over. So left click, hold, and drag to select the 0 through 8 and let go of the mouse button. Then hold down the control key and bring your mouse over to the column with the means in it. Left click, hold, and drag. So now you can see we've selected these 2 columns, but there's a gap in between. We didn't select everything. Then we're going to go up to insert, the insert ribbon, and we're going to insert charts. And we want this one. Okay, and we actually are going to choose okay, sorry, we're actually going to choose this one, the scatter plot. We're not going to choose the line or area chart. This one isn't actually programmed entirely properly for our purposes. So we want to always use the scatter plot, but we want to use the one where it's connected with a line. You could also choose this one if you don't like the dots. Either way, do not use the smooth one. Okay, that just won't work for our purposes. Use this one. Even though students think this one tends to look better, it means something different visually to a scientist or a mathematician. So pick this one. Okay, and I'm actually going to pull this down a little bit so we can kind of see our data as we go back and forth, and I'm going to change the size just a tiny bit. Now, there's all sorts of options up here. You can change colors, you could change formats, shading, shadowing. Don't pick this black one. As older folks, it hurts our eyes and it's harder to read. But whatever you do as far as like layout and font and making it pretty, do that at the end. It's important that you have the bones of it done first, basically. You want the parts that are required done properly before you're worrying about making it fancy. So every chart needs a title. So this chart title should be the same as the title of the table. So I'm going to just select everything and copy it, and then click within the where it says chart title, and I'm going to paste that right in there. Then we also have a problem. Oops, here we go. There's no labels on these axes, and that is entirely wrong. So we want to make sure the chart is selected, so you have these bubbles around the outside. Then click the plus and add the axes title. So now axes. And this is the x-axis title, the salinity, and it includes the units and precision. So I'm going to just copy that and paste it here. And then the y-axis is found here. Okay, so I'm going to grab my dependent variable, cut and paste it, and into the y-axis. Okay, so now we have appropriate labels. Now the next thing we need to do is add our error bars. So we're going to go back to the plus, make sure the chart is selected, and click error bars. But remember, Excel doesn't do them properly, so we need to program it to do what we want to do. So first off, when you click error bars, you'll notice you have up and down error bars, and that's because we had two quantitative variables this time, and last time we only had one quantitative variable. So if you just click on the horizontal error bars, you'll see that they've got these dots to show you that they're selected. And if you look here on the chart tools under format, you'll see series 1 error bars selected, X error bars. Once they're selected, just hit delete and they'll go away. We don't want those. We only want the vertical. Okay, then once you've deleted those error bars, if you go back to the plus and select the menu, we want more options. Remember, the standard deviation one is not correct at all. So more options, and then we'll have this format tab open up. Make sure both with the cap is selected, and we want to go back down to custom, and we're going to do these the exact same way as we did in the last video. So we'll hit specify value, and you're going to make sure this is selected and just delete it. And you want to select all of the standard deviations in order that match our X value. So left click, hold and drag. So we're telling it to go up by this value, and then selecting the negative error value, select this and delete it. And we're gonna left click, hold and drag to select the standard deviations again, and then hit OK. And you will see that the error bars are vastly different sizes. Okay, that's one quick way your teacher can check to know if you did the error bars correctly. If they're all the same, probably you didn't do it right unless your data was all the same. Okay, then on the graph, if you look on our original, okay, we also added in a trend line, an equation, and an r-squared value. So we're going to do that now. So select graph, make sure you have the circles plus, okay, and hit trend line. And then, so that part was easy. That one is done correctly. Open up the menu and let's go to more options. So the linear is the one we want. Sometimes your data may not be linear, and then you may need to select one of these other trend line options that would best match your data. In this case, the linear will suffice. Okay, and then we want to display the equation on your chart and display the r-squared value, and then you can just left click and move that to wherever you want it on the chart. Okay. Oh, and one thing I've forgotten that we did have in the other chart was that error bars represent standard deviation. And that's kind of large, so I'm just going to select that and make that note smaller. Okay. Now the trend line is the line of best fit, and this is the equation for it. R-squared is the Pearson's value. That tells you how close to the data is the line of best fit. Okay. So another way to calculate Pearson's besides just finding the r-squared value here and then finding the square root is you can do it through the formulas function as well. So I'm going to label what it is. It's not good to have a random number on a spreadsheet because I guarantee you later you will forget. So Pearson's gives you an R value. So I'm going to select here, this is where I want my answer. I'm going to go up to formulas, more functions, statistical. And there's two ways to do it. You can do it by scrolling down and selecting Pearson. Okay, so array 1 is going to be my X values, which is over here. And array 2 is going to be my Y values, which is the means. hit OK, and then that gives me this answer. Or in an older version of Excel, they had it programmed through the correlation function rather than the Pearson's function. So you can go up to statistical formulas and select Correl, and you're going to do it the exact same way. Select your X and your Y and hit OK, and you'll see that the two numbers are equivalent. It's just two different formulas. If you're older like me, you learned it on Correl. There was no Pearson's function up until a few years ago. Okay, and what this number tells you is the closer R is to 0, that means that it's going to be a very, well, if it is 0, it's a no correlation. But if it's, say, between 0 to, I don't know, about 0.3, then that's a weak correlation. And if it's 0.3 to, let's say, 0.7 or so, that one's moderate correlation. And then if it's 0.7 to 1, that's strong. Now the positive and negative indicates the direction of the line. Is it positive or negatively sloped? So in this case, we have negative 0.97. That's very strong because it's very close to -1. And since it's negative, it is a negative correlation. So if I were describing this, I would say this is a strong negative correlation between salinity and mung bean height. Or another way to say this would be, as the salinity increases, the mung bean height decreases, most likely because the salt is killing our mung beans. Okay. And these two data would also need to be rounded as well. This used all of this data here, so we need to actually round it down to one significant figure. So I'm going to go back to the home page, round it all the way down to 1. You're not likely to see a correlation so strong just out there. I made up these data to be close to 1, so that's why it is so close. But experimentally, you're never going to get exactly 1. And in fact, I need to round that to no decimal places. There we go, because it should only have one significant figure. Okay, and that is how you calculate mean, standard deviation, and the appropriate error bars on a line graph, and how to calculate Pearson's.